Okay, let's get started. Um, Today we will have a kind of like say it louder. The, we will have an evaluation at what time? At 11:30. Okay, so we need to go a little bit faster. Okay, so now up to this point, do you have any question? See, we learn how that we can combine probability, programming, and business knowledge together to make a optimum business decision. Yes.
But how would the payoff matrix look like in the bank data set? It wouldn't be a part of it, would it?
How would it look like? It's like actually we will cover that later on next week. Okay. But for your maybe after the I might not have time to cover that today. So if after the evaluation we still have some time, maybe we can cover a little bit about that. But before the evaluation, let's do more exercise on this one. Okay, on this one. Now, can you run the simulator in your own computer?
It's not working.
What?
It says that the Sim11BR data, there is no file.
There's no file.
Yeah, it isn't file.
So everyone got the same problem? So anyone can run the simulation? No? What's the problem? Let me see.
There's no file.
I think you need to set it as the working directory, right?
I did it, but this is my working directory.
Sim 11B, the R data. You do have that. So why?
I can set it again after working directory and file.
It's working now. So anyone cannot run the simulator? Raise your hand, please. You can run the simulator, right? Okay. So let's try to answer the this question just to make sure that everyone gets the a deeper understanding. What's the problem there? Okay, let's move on, okay? So we run the simulator, we want to answer the following question, okay? So first of all, we want to use the default setting, okay? The default setting is by default setting, I means that we don't want to change the payoff matrix, okay? I want to answer the first set of question. I want you to answer the first set of question, okay? With the default setting, which means that we don't want to change the payoff matrix, okay?
0.27.
Yeah, you just run the simulator and don't change the payoff matrix, okay? Just keep it the way it is, okay? And I want you to answer this question. So what is the optimum ratio?
0.27.
Okay, and what is the corresponding expected outcome?
Minus 183.1.
It's already here, right? It's already here. Okay. See? So the first question is quite straightforward. The second one, what are the threshold and outcome if we do nothing? If you do not take action at all, what would be the threshold and outcome? Expected outcome, I mean.
Same.
Same?
Because TN is no action. So, and no action.
If I take no action at all, what do we mean that if we set the threshold at 0.226? It means that we want to take action to those who has a probability of poor care more than 0.26, right? Isn't it? So there are so many people, right? There are this many people. We will take action, and these people we do not take action, right? So what is the cutoff and the result if we take no action at all? You can move the threshold, right? Okay. The higher the threshold, the fewer people that we will take action, right? So at what threshold we would like determine to take no action at all? You don't need to move this, right? This is just put it the way it is. From this chart, you should be able to tell if I do not take action at all, okay, what is my expected payoff?
Minus 200.
Sorry?
No action, the threshold would be 0 at no action.
Uh,
Or the threshold would be 1 or 0 at no action. So if it's
yeah, so it should be 1 or 0, one of it.
at 0, we need to take action for all the
Everyone,
people,
right?
And on 1, we don't need to take action for anybody.
Right, correct, right?
It will be so minus 250 would be the expected payoff at 1 when we do not have to take action for anybody.
Correct. You get the point? Everyone get the point? Right? So if I do not take action, if I set the threshold at this point, right? I end up taking no action on anyone. Right? Because I only take action on those who has a probability higher than the threshold, right? And if I set the threshold at 1, actually I would take action on no one, which means that I build a model, I do a prediction, I do a lot of calculation, but I do nothing, right? Okay, then it's not gonna help you at all, right? Okay, the entire practice will not help you at all if you like take no action at all, isn't it? Okay, so it's like if you set the threshold at this point and the expected payoff with about minus 250. Okay? So now next question. So it actually is the reverse, right? Question C, what are the threshold and outcome if we take action to everyone? Yeah?
Threshold 0.
No. That's give another classmate. Just. If I want to take action on everyone, then what is the threshold? Now think about the definition of the threshold. The threshold is the threshold of action in terms of predicted probability, right? Okay? And I will take action on whoever the predicted probability is higher than the threshold. So if I want to take action on everyone, okay? So what is the threshold? Sorry? 0, right? Okay. So what is the corresponding expected outcome? You can read it, right? From here, right? Because you already do the simulation, right? It's what the simulation is for, right? So it simulates that if you like apply that action to everyone, okay, you will actually have expected payoff of minus 200, okay? See, now you compare the 3 cases. This is the case that we take the action on everyone. This is the case that we take action on no one. And this is a case that we selectively take action, right? Which one is the best? Which is the optimum choice? So you're making business decision, right? You can take action on everyone. You can take action on no one. And you can selectively take action on someone, right? Which situation will lead to the best result? It's not too difficult to tell, right? the simulation tell you all of the 3 different cases. Which one is best? What do you say? Yeah?
Can you please repeat the question?
I mean, among the 3 cases, no action, all take action on everyone, and take action on no one, and then selectively take action on someone, okay? Which situation will lead to the best result?
The optimal one.
Yeah, selective one, right? Okay. So when you are making business decision, the decision is usually not yes or no. Okay? Someone asks you that, okay, I have this preventive medication treatment. Should I apply it or not? In the beginning, the question would look like that. Okay? But if you are a business analytic, you would tell your boss that we should selectively apply that treatment to this selective group of people. And that would help us reduce our risk of cost, reduce our cost of risk from 250 to 183, right? That is the power of business analytics. You get the point? Right? You get the point. See, and if you in this case, we can see that you taking no action is worse than taking action on everyone, right? Okay. So in some case it's different. Right? For example, like this case, if the cost is like jump up from 10 to 20, right? Situation change, right? So you can see that now if you want to apply action to everyone, it's worse than taking no action at all. You can see that, right? Because cost is higher, right? So now this is worse than this one. But still, the best situation is like to selectively apply it to a selective group of people. You don't know which one to select, right? because you actually have the predicted probability on every one of your patients. Okay? Of course, the prediction is not always correct. Okay? But the beauty of statistic is as long as you apply the expected value to a lot of people, right? The average would like kind of like approach the expected value. Right? Isn't it? Okay? So that's how it works. Okay, that's how it works. Now let's now let's consider another case. If we have a series of treatment, okay, the cost of treatment are 5. If I have 5 different treatment, okay, the costs are different, okay, and the extent that it can reduce the risk are different, okay. So the first treatment cost is only 5. It can reduce the risk from 100 to 70. Okay? So now I want you to adjust. You don't need to write program, right? Just use the simulator. I want you to simulate these 5 different cases. Okay? And then try to find out for each of the case what is the optimum threshold, the expected payoff. So and then which action has the best expected payoff. Okay? So it's kind of like now you have a more than one treatment, right? You can simulate by using the interactive simulator. You can simulate 5 different treatment, and every treatment will have an optimum, right? So you can choose between the treatments, right? Okay? So not only that you can choose between the patients, among the patients, you can also use the simulator to help you choose the treatment that you want to use. Right? That will be different, isn't it? It's 10:30 already. So do we want to do the evaluation first? I think there's people out there. You want to do the evaluation, right? Okay, let's do the evaluation first.
Do we have a QR code? Because,
Sorry?
do you have a QR code that can show on the screen if we don't have any?
可以用电脑跟上去。
Okay. So how?
我先 upload。
Or you can just scan on this paper. And there are 2 surveys on this QR code. It includes the teaching evaluation, and the second one is the learning outcome. You have to make sure that you have to fill in out these 2 surveys.
It would take like 10 minutes, right? Usually. I mean, how long would it take? Like 10 minutes also, right?
I think 20 minutes.
20 minutes?
Yeah, because we have 2 surveys.
Oh, okay.
Yes.
Okay.
I'm sorry. Are you the assistant for assist?
Finished? Okay.
Maybe the second one person is still feeling the
Sorry?
evaluation.
Okay. Okay. Finished? Anyone need more time for the? No, no. Just. Right. You should have done this a lot of time before, right?
For the whole semester,
Sorry?
you will have to finish all the time within one semester.
Yeah, yeah.
Sure, Professor.
You're done, right?
Mm-hmm.
Okay. Okay. So we have like 50 minutes left. Let's get back to our get back to this exercise. Okay? So now you have like 5 treatment instead of just one, right? And the first treatment costs $5 and it will reduce the cost of risk. It will reduce the risk from 100 to 70. Okay? And the second one is like $10 reduced to 60 and so on. So I want you to like use the simulator to simulate each of this treatment. Okay. For example, the first treatment has a cost of 5, right? So this is the cost of 5, and it will reduce the risk from 100 down to 70, right? So what is this TP? Should be how many? Is that 70 or not? Remember that this is reduced risk plus cost, right? So it should be how many? Yeah, it should be 75, right? So this is 575, and this treatment, if we are using this treatment, right, the cutoff should be 0.26, and the expected payoff is 217.56, right? Okay. So I want you to run the simulation for each of these cases. Yeah.
Professor, we did it 75 because we added the original cost of 5
Yes.
to 70.
Yes.
Why?
Because we are talking about this case, right? Which means that you reduce the cost from 100 to minus 70. But because you take action, right? You need to add that cost of action into the cost of risk, isn't it? Right? So this cell is a little bit tricky. Okay. Yeah. So you can do the simulation for each of the 5 treatment, and then among the treatment you can select the best one, right? The one who give you the best result, isn't it? Right? Do you want to try it now?
Yes.
Yeah. Within your team, okay? You already get the answer?
No, I have a question.
Okay.
Do we need to change the FN bar?
No, don't change the FM bar. I assume that the TN and FM bar are, right, fixed, right? Because we are not only concerned, I mean, the variation is only occur on cause and effect, right? So between your team, right, you can like gather together and can you find out what is the best treatment that we want to use? Yeah, you can get together and try to like down, right? You need to like try each of the five cases and write down the answer, right?
What
Yes.
does it mean when, because it states and reduce the risk from $100 to 70, 60, 50, and then 50, but we do not adjust the 100 bar in the module.
See, actually, uh,
So now we use reduce the TP,
yeah.
but do you ever reduce the FN?
No. Don't do that. Don't do that. Right. The FN thing is that the risk that you do nothing, right?
Yeah.
Yeah. So it would not be affected by the treatment at all, right? Because Whoever finished, whoever have an answer, please raise your hand. Only one? Okay. Oh, two people.
Like the whole team has that.
The whole team already had that. Okay. So it'll be easy after you do the first one, right? Second, third, fourth, the fifth one should not be too difficult. You finished? So what is the problem? Yeah, you need to write down because in this simulator you only show one answer at one time, right? Um, I guess we are kind of running out of time, right? So let's see the answer of this is which group are you?
Group one.
So this is group one. So what is your answer?
1 and 5 is our answer because the expected payoff for $5 is 217.56 and the expected payoff for $35 is 217.53. So there's not much difference, but if it's about accuracy, then has the highest expected payoff.
Not that doesn't seems to be the correct answer though.
We had number 4 in 207.1.
Yeah, number 4 is the correct answer. Yeah.
But that is the least, right? We are looking for the highest.
But it's a negative number.
Yeah.
Oh.
Yeah. That's the negative number. Yeah, it should be the number 4, right? Right. You get it wrong. Because this is cost reduction, right? So all of the number are like negative. Okay. Okay. The actually the reason that we do this exercise, right, is to show you that this model and simulation can help you with a lot of things. Okay, it would help us make the decision, and the decision is not just do it or not do it, right? It first of all, if you have a lot of different alternative instrument, it helps you to choose the instrument, right? This is the exercise that we are doing now. Then after you choose the instrument, it helps you identify to which subject you want to apply that instrument, right? That is the reason, the major reason that we want to learn business analytics. Okay? So starting from next week, we'll have 2 weeks left, right, before our final. So the next 2 weeks, I will go back to the Tafang case. Okay? Now, in the Tafang case, first of all, I will show you how to make a model to predict the repurchase probability. Okay? And we'll make another model to predict the expected buying amount. Okay? But with this prediction, it's not no decision, right? What is the decision that we are talking about, right? You know these two things, then we are going to do like kind of like a business planning, a marketing planning, right? So we will have some assumption, right? We have some marketing instrument, for example, a coupon, for example, a discount, for example, a loyalty program, an event, something like that, some advertisement, right? But all of this instrument has a cost, and their effect will be, they will have an effect on the repurchase probability or on the buying amount, right? That's how marketing instrument works, right? Every marketing instrument has a cost, and with that cost, you wish that you can raise the probability or raise the amount, right? But so far, we do not have the data of the instrument yet, so we do some assumption, right? So after we do the prediction, we will use some assumption on the marketing instrument, and then together the assumption and prediction will make simulation, and then we'll choose our optimum action, right? Which means that in your final report, you will choose among a few different marketing instruments, okay? Be that coupon, discounts, advertisement, whatsoever, right? And of course, their cost effectiveness are assumed because we do not have real data yet, right? Okay, then you choose among the instrument, and then after choosing the instrument, you will choose the subject to apply the instrument, and then right, you choose among instrument. Here, you would, given instrument, you want to choose the target that you want to apply the instrument, and then you want to evaluate when I apply this instrument to this group of person, what is the expected outcome? Okay, that is our final project, and for the next 2 weeks, I will help you do the model. I will help you do the simulation. And in our final presentation, I want you to like do your own assumption and do your own simulation and present your results. Is that clear? Okay? And that would kind of like wrap up our entire course, isn't it? Okay? So we already run out of time. It's 12:05 already. Sorry about that. So if no question, that's all for today. I'll see you next week. Okay. Sorry. This week's homework is like, first of all, it's we have 2 notebooks, right? Okay. Like just finish and knit the notebook and send it as your personal assignment. That's it. Okay?